So one of the big reasons we collect all this beautiful data in Wikidata is so people can build really cool stuff on top of it. And I'm very excited that one of the really cool things that's being built on top of Wikidata's data is Abstract Wikipedia. And today, Ariel will talk a bit about some of the problems they encountered while using the data so we can make it better. Ariel, go for it.
Yeah, thank you very much, Lydia and Leah, for giving me this opportunity to speak in this event. And I apologize that I couldn't attend the other session before me, but that was not out of a lack of interest or other constraints. Anyhow, I suppose you all see my slides now. Well, let me shortly introduce myself. Normally I'm in software engineering at Google, but as part of a so-called Google Org fellowship, I'm working with the Abstract Wikimedia team now for a time of about half a year. I've started in May, and my goal in the Abstract Wikipedia team is to set up the initial design, hopefully some prototype of the natural language generation pipeline for the Abstract Wikipedia project. And as part of that, I have also started looking at the data in the lexical data in Wikidata, and that's the subject of my talk today, indeed. So, okay, so maybe not all of you know what the Abstract Wikipedia project is about. So let me tell you that the ultimate goal of this project is to be able to, on one hand, represent articles in a language agnostic way. That is the so-called abstract content, which will probably be stored on Wikidata. And then to use natural language generation techniques to render this content in different language editions of Wikipedia, most notably those which don't have that topic present. And the idea is that in that way we can expand the reach of articles to all available languages of Wikipedia, reaching out to more people in the world. By the way, you did see that my slide changed, right? Just to confirm that now.
Yes. Yes.
Okay, so here is the architecture of Abstract Wikipedia as conceived by Denny. I won't attempt to pronounce his last name, but you probably know him. So the arrows here should be understood as a dependency. So you see that Wikipedia, the articles generated by Abstract Wikipedia will somehow depend on this abstract content, which you can see in the Wikidata part, which will then depend on the existence of render. I mean, well, maybe it's not strictly dependency, but anyhow, we will use renderers to render this abstract content. As I said, this well, there will be all kind of functions and types and constructors. But at the end of the day, what we really need in order for this to work is Lexemes. So everything at the end depends on Lexemes, and these Lexemes, as you know, are stored in Wikidata. So really, the success of this project lies to a great deal on the lexicographical data, its quality and coverage within Wikidata. And here is a kind of mock example of how data might be used and what might be the problems here. And as you see, this actually, I'm indebted to Nicolas Vigneron for drawing my attention to a specific lexeme here, which has some interesting properties. So let's look at some content we have in Wikidata. I have a bit abstracted away from the notion of abstract content. We can also assume that we would be able to render simple facts which are already present in Wikidata. For instance, if we look at this item Q14560, it's about cactuses or cacta, in Latin, I suppose. We see that this kind of plants use some kind of special photosynthesis. Anyhow, okay, so we now want to generate this in English. So we have, actually English is probably not our first target language, since we want to render in Wikipedias which have actually less content, but for the sake of the example, I think it will be, it's a good simple example. So anyhow, in English, we know that in order to tell general claims, we normally use the plural. For instance, we could say something like, cacti use CAM photosynthesis. And indeed, if you will look at the article about cactuses, you will see that there is a more elaborate claim like this in the real article, which is of course not rendered but written by an author. So anyhow, going back to our energy pipeline, energy is natural language generation, we see here that we should be able to, the item itself is linked to a lexeme, to the cactus lexeme in English, which is, I think, L4460. And that lexeme has currently, after some fixes which Nicolas Vigneron made, has currently 4 forms. One is the singular form, and then we see 3 different plurals, as indeed there are 3 different plurals in use in English. The most common one is cacti, then we have cactuses, and in fact, even the form cactus can be used as a plural. So you see here that our energy pipeline will already run into a problem. There is no way to distinguish, there is no distinguishing criteria between these 3 plurals. So there is no clear way to select which plural to use. So we might say, well, we take the first one, that would be F2, and indeed that this happens to be in this case the most frequently one, I think, the most frequently used, cacti. But in general, we want the data in the lexical data to be as, let's say, crystal clear for the energy pipeline to select the right forms. By the way, there will be, as Lydia mentioned, some time at the end to ask questions, and that will not be recorded. However, if you don't mind to be recorded and you want to ask a question in the middle, feel free to raise a hand or, yeah. I am also trying to monitor chat, but it's a bit difficult anyhow. So the best would be to raise a hand and pose a question, especially if you have a clarification question. Okay. So here we saw one issue in this cactus lexeme, and the issue is that we, in fact, don't have enough data to discriminate between the different plurals. For instance, ideally there we would want to have something like a rank or maybe a statement attached to the different plurals saying, well, this is the plural we should use in the NLG, this is the most, or maybe more general, this is the most frequent plural to use in the general context or something like this. However, there are other problems which I think are even a bit more problematic, and these are inconsistencies we can find in lexemes. So we can find inconsistencies both within lexemes and also across lexemes. And even, I mean, this is expected to some extent, but even there is unneeded inconsistency across languages. And here I'll give you some illustrative examples. So these examples are not maybe I mean, one could discuss each example in depth, but it's really just for the sake of illustration, not to say that they are the main issue for our talk. So here you see, for instance, a noun in Hebrew. Now the Wikidata Hebrew, the lexical Hebrew data has especially some problems, but again, this is mostly illustrative. And you see that there is a statement telling us that the grammatical gender is masculine. This supposedly should be applicable for all forms of this lexeme. However, we see already form number 1, which tells us that this form is feminine. And there is also another minor issue here, which is not so important, but still we see that the lexical category is given as noun, but this is also repeated on the form, and in fact on all forms. Yeah, indeed, Hebrew needs some work in lab. Yeah, I looked at specifically the Hebrew examples because it's one of my native languages, so it was easy for me. But this phenomenon of having a statement being in contradiction to the features given on forms doesn't happen only in Hebrew. It happens in other languages. And the problem with that is that in our energy pipeline, we would ideally like to rely on the statements given on the lexeme entry level itself. So we don't need to traverse all the forms initially. But if they are in contradiction, then in fact they are not usable, and we would anyhow need to look at the forms. Okay, let's look at the second example. So here is an English example. Well, okay, this is someone there is something inconsistency here with the language code. We see that ENUS hasn't been used, but someone has answered to me about us in the Telegram group that this is some there was some historical problem which since has been fixed, but we see that this fix has maybe not been propagated to all of the Lexemes. Um, okay, but the main point is here actually not this specific lexeme, but rather we will um, compare this lexeme now with another verb. So you see here, just have a look that we have here the I'm a bit confused here. What? Let's go back to this later. I'm actually not sure why I show this except the language code. Yeah. Okay. Let's go back to Hebrew. Hebrew is much easier. So you see here now another type of inconsistency within lexemes. Here you see that we have a statement of the form feminine or masculine. That's maybe not ideal because this means that our energy pipeline would need to handle this kind of disjunctive statements, but at least it's clear. I would, in such a case, if it's both feminine or masculine, I would simply remove this statement because, in fact, there are only two genders in Hebrew, grammatical genders. Or what we could also do is to add, and maybe I've even done that on this lexeme, we could add some rank saying that, well, this is feminine or masculine historically, but the currently used gender is, in fact, feminine in current Hebrew. However, the problem comes when we look at the forms. We see here that we have both masculine and feminine on the forms, and this might seem logical for a human reader because we know this is both could be masculine or feminine. But from a machine readable perspective, there is no disjunction here. So, in fact, what the naive code might find here is say, well, this form is both masculine, feminine, singular, and a noun, and this could lead to a clash if the grammar tells us a noun needs to be either feminine or masculine. So again, we need to find some consistent way to represent this kind of variation. I think in the case of Hebrew, we could just remove the gender information in that case, because in fact, any gender is applicable for this noun. But there could be other solutions. Okay, now we get to an example of inconsistency across lexemes. Here we have three different verbs in English. And you see, although we have, in all of the cases, I've taken the form which is the third person singular in the present, each of them uses another set of features. So has used third person singular and simple present. While in the case of the verb to be, we see that, and also of the verb to go, we see that the third person and singular have been collapsed into a single feature, the third person singular. And also in the case of the verb to be, we see that instead of using the simple present feature, we use another feature, present indicative. This might have been motivated for the verb to be by the fact that one can use the subjunctive form, especially in the verb to be. But it complicates again our energy pipeline because now it needs to be aware when it selects a form that, well, the simple present could in fact be represented as present indicative. So again, there should be some consistent modeling across lexemes, so all lexemes can be processed in the same way. So as I've hinted already in the examples, in order to solve this, we need a very clear linguistic model of lexicographic data when we create such data. Now, this is maybe a bit difficult because, of course, one of the ideas in Wikipedia and Wikidata in particular is that people can add data on a sporadic basis. That is, I'm an editor. I browse the site and I see there is some error. I want to add something, and I add it, and that could maybe work quite well for general items. But for lexicographical data, since we need to adhere to some overall model, I need to have some knowledge of that, or ideally there should be some UI that prevents me doing additions outside this model. I think this is not yet present. Still, I think we can reach, still the fundamental problem is that, as far as I could see, there has not always been defined a clear model in all of for all of the languages. So let's discuss this now a bit more in detail. Well, there has been some approaches taken for this. Of course, we have the documentation pages for languages. Some of these are very detailed, some are less detailed. As far as I could see, they do not follow in general a single kind of format. So if I, for instance, would like now to add the Lexemes in Swedish, I would need to go to the documentation page for Swedish and read what's going on in Swedish, but I wouldn't maybe immediately be informed just by looking at the format of the page how I should approach the data in Bengali, because in Bengali, as I said, it's very detailed, but it follows its own format. So I think not only should the documentation, of course, be improved for language, ideally there should also be kind of the same questions answered in the different documentation pages, like, for instance, which parts of speech do we need, which features do we need for each part of speech, etc. Now, another way in which we can enforce consistency in Wikidata is these Lexeme forms. These, as some of you may know, are forms which allow us to easily create new Lexemes and by means of examples. And once we have done that, the forms are populated automatically within the page. And this is a great idea. I mean, one needs, I think, to install some extension to get it working. But the problem is that these Lexeme forms are not always consistent with the existing data, and also not with the lexical mask, which were the third approach to solve this problem. The idea with lexical mask is that we define a lexical linguistic model of Lexemes. That is, we say, for a given part of speech, we should use such and such many forms, and these forms should each have these features. And that is indeed getting closest to what I'm trying to advocate here for. But again, the problem is that these lexical masks themselves are not run automatically, so one has to run a validation script. So they're not really enforced systematically, and they're not always consistent with the forms, the Lexeme forms. So these forms to add forms, and neither with the documentation. Okay. So as I said, I'll go on unless if there is some clarification question, please raise the hand, because I'm having trouble to look at the chat at the same time.
Yeah, I will keep an eye on it.
Thank you. Okay, so I would suggest approaching the problem with some basic principles, and of course, I'm presenting this in somewhat an assertive tone, like I'm telling what I think should be done. But of course, this is all open to discussion, and some modeling problems are quite hard, in fact, as you will see. So I don't think there is one golden answer. Rather, we should take a kind of pragmatic approach, given the pipelines that will consume at the end of the day this data, how data should look like. So one thing might seem quite obvious when one reads the general documentation of the lexical model in Wikidata is that Lexeme forms should be used for grammatical inflection. And in the documentation page for the data model of the lexicographical data, one sees this phrase: there should be one Lexeme form for each relevant combination of grammatical features. Grammatical here can be understood mostly as morphological features, that is inflection, but it could also be phonological features. For instance, if you think of the English determiner it can also take the form an. So we could think there is, well, this is a one-time occurrence in English, but in other languages it's more usual. So we could think of a special feature distinguishing these two forms. However, this very simple premise is not respected in many cases, as we saw just in the cactus example I showed in the beginning. We have 3 different plurals, and these are not distinguished by neither by the grammatical features nor even by some statements. And I think the problem is that since Wikidata is having a very rich data model, people want to use different kind of variation. They want to show different kind of variation. The variation could be, for instance, dialectal variation in Lexeme, regional variation, orthographic, historical. It could be abbreviations of features, and sometimes it seems the most natural thing to do is to add more forms. However, this breaks this premise, which we just discussed, having one form for each grammatical inflection, not for other things. So I would advocate to try to encapsulate other kind of variations in other parts of the data model. For instance, if we have systematic regional or dialectal variation, and especially if this causes a difference in the pronunciation or in the grammatical features, maybe we should just create distinct lexemes with the appropriate language code. That is, we could have a different lexeme space for each important dialect of a language. Sometimes one could say, for instance, in the case of the British English and the American English, that maybe this is mostly orthographic variation or kind of very light variation in the pronunciation that is kind of systematic. So we don't need to create a different lexeme for color and color, for instance. So I think in these cases, indeed, it is very logical to use the spelling variants, but of course, this also needs to be done in some consistent way using a consistent set of language codes. More difficult is the question of how to represent historical variation. So let's say I have, as I mentioned, in Hebrew, I might have a noun that historically was masculine, but nowadays is feminine, or vice versa. So it feels unsatisfactory to create two lexemes for that, and indeed, linguistically, it might be wrong. So here we should, as much as possible, I think, if this distinction can be made on the lexeme level, for instance, the gender has moved for all forms, then the easiest way would be to put the statements on the lexeme level. And as we know, we can qualify statements and rank them. So that gives us the possibility to say, well, this was the historical gender used up to year that and that, if we know. But now the current used gender is this one, and we can give the preferred rank. And then we can instruct our energy pipeline, whenever possible, use preferred rank statements. It is a bit more complicated when we have a variation in a specific form, because the data model of the lexicographical data doesn't, the features are not statements, so they cannot be qualified. And my understanding is that this is very difficult to change at this point. So here, I mean, one could take different approaches. I think maybe the best approach, at least for the use in Abstract Wikipedia, would be to give the lexemes use the main feature space on the forms for the current use features, and maybe give a qualified statement about an historical feature. That is assuming that the form itself doesn't change. If the form changes, then we might need to add some feature to distinguish it, maybe the archaic feature or something like this. And having given that feature, we can then give some statements about when a specific form was used. I must say I don't have here a very satisfactory and cover-all answer for the historical variation, because it's a bit of a complicated problem. I think we need to look at it in maybe case by case or language by language to think of good solutions. Another thing I've seen, which I found a bit puzzling, is the use of the abbreviation as a grammatical feature. Abbreviation is, of course, not a grammatical feature in the linguistic sense of the word feature. In some cases, if there is a frequently occurring abbreviation, say we write MR dot for Mr., this could be seen as a spelling variant, but it's important to note that we still pronounce it as the full word. If it's a domain-specific variation, say, I think there was a discussion recently about postal addresses abbreviations in the US, then maybe it makes more sense to have a specific property and say, well, the abbreviation for this form, or maybe for the lexeme entirely, in this domain is such and such. But again, I wouldn't list it as a grammatical feature because it muddles the idea that lexeme forms should be used for grammatical inflection. Okay, I hope I'm fine with the time. Yeah, about. Okay, so let's go to the next principle. Use Lexemes statements for recurring features. So the idea here is that if we have a feature that is repeated on all of the forms, for instance, we know that a certain noun is feminine, there is no point of listing that again and again on each form. Rather, that should be a statement on the lexeme level. And similarly, of course, for the part of speech, which is part of the lexeme definition. This in general has been, I think, again, I've seen cases where it's not being observed, and we saw cases where it was even inconsistent, but I think it's a simple principle to go by. And the idea here is that if we do that consistently, the downstream pipeline can rely on the lexeme statements before processing the forms. So if since it knows that this statement applies to all forms, and moreover, it knows that features which are true for all forms would be stated as a statement on the lexeme level. There is an interesting case which I have recently been, my colleague Kutz have drawn my attention to, that in some cases I might have a noun, for instance, in Spanish, which inflects for gender. For instance, she pointed out to me the noun gato, that is cat. Of course, in Spanish, it can be a feminine cat or a masculine cat, depending on the biological sex of the cat in question. But in another sense, there is a sense of a mechanical jack for the same word. It would only be masculine. So the question arises here, should that statement be put on the sense level? And if you go to the Lexeme Gato, you see that is what I've provisorily done. It's not in my presentation, but actually I don't think this is the best solution. So if you have a Lexeme, which in one sense has an extended paradigm, and in another sense has a narrower paradigm, I would split it into two lexemes here. You can have a look at this here, because otherwise we would need to look at the grammatical statement per sense, which would again complicate our processing. Okay, now let's go to another principle which I would suggest, and I think this has even been accepted in some discussion I saw on one of the discussion pages, and that is the idea that we should always prefer atomic features. That is, instead of using, for instance, third person singular as a single feature, we should have a third person feature and the singular feature. And similarly, we saw the present indicative, so we could say, well, we have present tense and indicative mood as two separate features. And the reason here is, again, that in the energy pipeline, it's easier to deal with atomic features. We might not, because of course we can easily combine atomic features as lists, but to know which features combine to a single feature would require some extra mapping, which is would be annoying. And also we saw that this leads to inconsistencies within the lexemes themselves. So I think this is a simple rule and is to follow, and we could even automate its application. There are, of course, cases where you have specific categories for language. For instance, in English, you have the category simple present. That category could, in fact, be seen as a combination of tense and aspect, so present tense and maybe habitual aspect. But I suppose it's okay for a given language to say, well, we want to stick to some traditional and understood labels, so we prefer to use the simple present because it's a known feature, or it's a known concept in English rather than the full linguistic analysis. So that is okay, but when we do have a feature which can clearly be divided into two sub-features, that should be done, as in these examples. Okay, so so these were the kind of general principles. Maybe we'll have another one in the continuation, but how should we go on to when we want to approach this problem? As I said, we need to rather than starting with the lexemes and giving kind of ad hoc annotation, we should start with a model. And And we should, in fact, start, in my opinion, with defining which set of features are relevant for a language. Not only is it we can start with language, and when we're looking at each language, we will actually see that every part of speech has different features relevant to it. For instance, in many languages, in German, we have the feature of case, nominative, accusative, dative, genitive. Of course, this feature is irrelevant for verbs in German. Once we have done that per language, and within each language per part of speech, we might also want to use the same vocabulary or features universally, that is for all languages. That is a bit difficult because different languages are sometimes described with different terms. As I said, the simple present is an English-specific term. But if there is an agreement within the different communities annotating different lexemes in Wikidata, I think that would also be ideal. Now we need to inventorize these features. So as I said again, each part of speech requires specific grammatical categories, or these are the feature types. So we need to distinguish between the category, for instance, the category of gender, and the features that category can take. And if we want to have if we know this category can be recurrent for all lexeme forms, we actually also need a property in order to mention it as a statement on the lexeme level. And as we know, we need to have a clear inventory of the features. So we need to say that each feature can take specific values. And I would recommend using the instance of property on the category item to list these features. And if we manage to have a universal model, we can just say, well, these are the instances of this category, or there might be cases where we want to qualify and say, well, this is a feature which is only applicable to language X, so we can qualify it. So as a simple example, here is the gender category. And if we are thinking about Swedish, we know that there are, in fact, 4 types of gender in Swedish. There is the masculine, there is the feminine, there is the common, and the neuter. So you might be a bit surprised here because Swedish nouns are typically only common or neuter nouns, sometimes or other terms are used. But if you look, for instance, at the Swedish pronouns, you see clear, the third person pronouns, you see clearly there is also a masculine pronoun, a feminine pronoun. So in fact, all these 4 genders exist in Swedish as grammatical genders. And as I said, this would be, all the blue boxes here are items. The gender item should also have a gender property, and this is indeed the case. But well, we will see what's the current situation later. Okay, so so as I said, here is an example of an inventory of features we could have in Swedish. So the verbs, we need tense, could be past or present, voice, active, passive, mood, infinitive, imperative, participle is something called supine in Swedish, and the indicative, which you can leave maybe as an unmarked feature, and I'll get back to that concept later. For nouns, we say, okay, the gender can be common or neuter, and I marked it in bold because it should be on the lexeme level statement. And then we have other features which are relevant for the forms, the singular or the plural, definite and indefinite nouns. These are morphological categories in Swedish. And then we have the case, the unmarked case, and the genitive case. So we can already count here and see that a fully specified Swedish noun in Wikidata should contain 8 forms. These are to some extent predictable, but I think we can do an eager. So we could populate them, for instance, using some kind of only giving the stem, and maybe well, for instance, genitive is very predictable, just adding an S, so it could be populated automatically. But let's say we have eager calculation in Wikidata, so the energy pipeline doesn't need to do this extra calculation, can just fetch the data. So, however, for pronouns, we do have actually also pronouns for masculine and feminine. We have also the demonstrative pronouns for common and neuter. We have the number feature. So again, for a pronoun, if we assume that the single pronoun is a lexeme, then the number would also be a statement level, a lexeme level statement. And the problem is right now there is no number property or grammatical number property, so that should ideally be added. And here we have even 3 types of cases, nominative, genitive, and oblique. And for adjectives, we have yet other features, um, and it gets a bit more complicated. But rather, so my point is that rather than starting with a lexeme, we should rather try to inventorize from the onset the different features in a different language. Say we start now a new language in lexicographical data in Wikidata. And once we have this inventory, we can set up everything we need, the documentation, the lexeme forms, the validation, etc., etc. And of course, also set up the features as items. And this is the next point I want to make. So in linguistics, the features are mostly not flat. We can actually hierarchize them as subtypes of each other. Um, so for instance, in Swedish, um, we can say, well, we have the root is the unspecified gender, and then we have the neutral gender, we have the common gender, and masculine and feminine can be seen as subtypes of the common gender. This, of course, also true historically, but there are some grammatical phenomena that can show that this is also true in synchrony. That is, if we combine the use of, for instance, if you have a masculine referent, for instance, a masculine pronoun, we might later qualify that with a adjective which has a specific masculine inflection together with a common noun or something like this. So how are we to represent this hierarchy in Wikidata? Well, I think the most natural way would be to use the subclass of property, which already exists for items. However, it might be slightly confusing because if you followed what I was saying earlier, I also suggested listing all the different atomic features as instances of the category class, that is of the gender class. So that would mean that masculine would be seen both as an instance of gender and a subclass of common. Common would be seen both as an instance and a subclass of gender. So that might lead to some confusion. Another approach would be to create a specific property linguistic subtype of. I leave that open for discussion. Let's see what's the current state of affairs. Is this organized in such a way? So I've used this useful Wikidata graph builder tool. And if you see, and I just explored one level of some instance of gender. As I said, ideally we should have well, I spoke about Swedish, but ideally we should have here a quite a limited list. And we see that in fact we have many, many different things. We have, which some are clearly grammatical, like common, feminine, but some are not really grammatical features, but somehow maybe related to some other aspects of the lexeme. For instance, unstable gender, maybe this is something historical, or aquatic terrestrial, I don't even know what this is. Or we have grammatical gender in German, which is shouldn't at all be seen as a feature of gender, right? It could be seen as, it should rather be annotated as a subclass of gender systems or something like this. Anyhow, so I think it's fair to say it's a bit of a mess. If we now look at the subclasses, which I said could be seen as subtypes in the linguistic sense, we see that this is not really the case here. We see all kind of items which I think are related to gender, like grammatical gender in French. You see this, by the way, also here inconsistent because we saw that the system, in German it was an instance, in French it's a subclass. Well, anyhow, none of these should be listed in such a way, in my opinion. We have, for instance, epicenity, which means being of two genders. I mean, of course, the problem is that the notion of subclass and instance can be understood both in linguistic and non-linguistic senses, and then this creates this combination of very different items here. But this is again problematic for our NLG pipeline because ideally we would